So Matt, hey, I haven't seen Tom Atkins lately. What's been up with him? You guys know anything? I always look for him when I go to McKay's, and he's never there lately, like for a while. Yeah, Tom's back was hurting him for a while. I'm not sure how that played out.
So the dark side.
Hey, would you do me a favor? Give me one of the blue Gatorade.
Dark side. Dark side.
So Matt, you can hear this going on the Facebook channel.
Hey, Dustin.
No, yeah, you can hear people talking.
Well, yeah, it might be just not showing up. You mean it's just iconized with your initials?
That was all memberships, and $221.11 for debits. And that was for like Whereby, and I think GoDaddy charged us a little bit more. So we have a total of $1,657.61 as of the 8th.
Okay, great. Any questions? All right. All right, continuing on with any correspondence. Dustin, have you seen anything on the, I know there was a discussion that we were talking about was it the Luminous project, the Luminous?
Yeah, I don't think that was me, was it? If it was, I forgot, and I apologize. I was working, if you remember our event last year with Memorial Hospital, I had some interaction with them to do a remote kind of star party for that again this year. But that's still a little ways off. I'll follow up on that.
Okay, anyone else? All right, we'll get into the community reports. So Ralph, thank you for setting this program up tonight. Do you have reports for the upcoming programs?
Okay, well, tonight, thanks Stephen Clements for doing this.
Okay.
He got it set up, and then I finished it up to get all the final stuff done. But Stephen set everything up. Next month is Kevin and Amy going to do a program on the moon geology, we think. Is that right? And then November, we're set up with Charlie Warren.
Okay.
Stephen's sorry he's not here, but he is in class up at Tennessee Tech this evening. So
Actually in class, all right.
Yeah, well, they've been doing it remote, but his professor decided there was something he wanted them all to do this evening, and Stephen's like, oh, great, it would be the evening of the PAS meeting that he had something to do with. But it's being recorded, isn't it, Matt?
Yep.
Okay, then he'll see it.
Okay, newsletter. Beth, again, thank you for all of your work. We really appreciate it. Do you have any reports or anything you need from the for the newsletter?
Just if anyone is interested in submitting an article, I mean, Ralph is just rocking it out of the park every month, but I'm sure he would love to have some help. So, you can submit an equipment review, you can submit, about a trip that you've gone on or something interesting you've done through astronomy. Anything that you want to submit, I will look at it. And if I feel like it needs to be tweaked, I'll let you know. But more than not, we typically accept pretty much all of our submissions. So if you have something you would like to share with the membership, please let me know, and I'm happy to put it in the newsletter.
Yes, please. Really, I mean, it's tough trying to put a newsletter out when you don't have the information there. And pictures, if you have equipment reviews, if you have questions, we could go on. We have the Group IO. We could maybe do a best of Q&A from Group IO I know we have new members here. So lots of opportunity for content for the newsletter and really to help share information around the society. So please, if you have any ideas, please submit them to Beth. And Beth, thank you again so much for all that you do with the newsletter.
Thank you, Patrick.
All right. 100 year, we'll talk about the nominations, and we've talked about the membership. 100 year, anything new on that front?
Is anybody in the group interested in trying to do a high altitude balloon launch?
Yeah, I think that's something that we had talked about. We got some information from some other clubs that had done the same thing. So,
Who's that? Oh, WB8ELK is that. If anyone is interested, write this down. It's his call sign. It's Whiskey Bravo 8 Echo Lima Kilo. WB8ELK, and it'll come back with the kind of stuff that we could track and do. And my idea was to use, I'm going to do it with a Beads of Courage launch if Gene, the director, goes for it, because we can put a message line on the balloon and then you can track it wherever it ends up. So a message line on the balloon data, I should say, that will show up on the tracking screens. So look up WB8ELK and the kind of high altitude balloon games he likes to play. And yeah, he was not interested in helping me until I told him it was Beads of Courage and Bernard Society. So he was probably primed for you, Matt. The last comment I got when I was talking to Bill at the Hamfest last year about it, he was, he's a senior guy, and he's working on the new, I don't know what he did in Missile Command, but he works on the base in Huntsville, and he's going to be deeply involved in the new missile system. So he was saying the NASA rocket. So he was saying that was fixing to crank up big time. It may have already. So he might need quite a bit of lead time if he's going to be involved in helping us, just to keep that in mind. And I'm done.
okay. All right, great. All right, moving on. Instead of jumping into the elections right now, I'm going to talk about a couple of other things first. Just traditionally, we have a field trip in November and a holiday party in December. And of course, situations being what they are, we don't know whether we're going to be able to do those things, but do we want to try to plan some type of field trip or some type, I know, Ralph, you had said you'd set up a program for November, which I don't think those two are mutually exclusive. We could do the program and have the meeting and also have the field trip. So thoughts on that?
Well, we decided a couple months ago to not do the field trip. If we do a field trip, it shouldn't be on the night of the club meeting, because I've already set Charlie up.
Yep.
And he's got us down. He's looking forward to doing the meeting, the program. So if we do a field trip, not do it on that night.
Right. Like I said, I don't think they're mutually exclusive things. Another opportunity is we could do maybe a outing at CLC if the weather's cooperates, something like that. And holiday party. Do we want to plan? We can always cancel it, but if we don't plan for it, we certainly won't be able to have it. That's fine with me. I just wanted to bring it up. Okay. So with that, I'd like to get on to the elections. So we asked for a slate, which we got, and we asked for nominations from the floor for anyone else from the floor. There were no other new nominations, so I would make a motion that we elect the slate that we have here instead of going through each one, since all of them are running unopposed. I'll go through this again. As the nomination for president is Amy Brock Hahn. Amy, can you raise your hand? Hi, Amy. How are you? For vice president,
I am
Dustin
good.
Fleming.
Hi, everyone.
Dustin, can you wave to everybody?
Hello, Amy.
Hey, thanks everybody.
Okay. For treasurer, Janet Wages, and she's been in office. She came through about halfway through the term when our previous treasurer resigned, and she has offered to continue on with that. So thank you very much, Janet. I know you're here. And Nakota Jude as secretary. Is Nakota online? Yep. Okay. So I would like to make the motion that we elect the slate as presented.
Second.
All right. All in favor?
Seconded.
Oh, yeah.
Aye.
Aye.
Thumbs up.
Aye. Aye.
Is there anyone opposed?
Patrick, I think you.
Outstanding. All right, so the motion carries, and we have elected the new slate of officers as proposed here. They will take over. We'll slowly transfer those responsibilities so that they will be up and running and managing everything by next month's meeting. So I will work with Amy and to make sure that we transfer all the things that we need to, as far as documents and materials, clear out my garage. Give you lots of new toys to play with. So thank you very much. And if you want to have anything to say, I'll start with Amy. Anything that you would like to say to the group?
I'm looking forward to the next few months and interacting with everybody and having a good time. And something I like to focus on is education and outreach. So just let you all know that that's where some of my attention is also going to go. Excellent. But I look forward to seeing everybody.
Dustin, anything?
Yeah, like I said, thanks everybody. I agree the outreach and the education, and I think I've only been a part of the group for a couple years now, but we've seen like our social media stuff go up by thousands. And with the things that Matt is doing on streaming and the way that we're seeing the increased interest in STEM education, I really think we've got a lot of exciting things coming in the next few years. So I'm honored to be a part of it and help out any way I can.
Great. Thank you, Dustin. Jan, anything you want to say?
No, I enjoyed doing it, and it's been an honor. And I'm like you guys. I want to continue with the education and the outreach.
Great. I appreciate all of you doing this. I know and I encourage everybody else to step up. And the other thing I want to mention is thank you to all of our chairmen for the membership committee, program committee, newsletters, publicity. So if you're interested in taking a little bit bigger role, you can certainly hop on to one of those committees. And if you have an idea for something, we can always start a new committee. So that's something that's up to the discretion of the new president. And if there's people interested in stepping up, believe me, all the help that you offer will be appreciated. So thank you to our new officers, and we will be hearing more from them in the coming months, and thank you very much. I appreciate it. Okay, so the last items on the agenda. Any announcements or any information that the club members would like to share? We haven't covered already?
I'd like to say something. It kind of goes along the lines of how well the society seems to be doing. I'm a member. Well, I'm actually on the board of directors of Chat Lab, the makerspace downtown. I'll put a sales pitch out for Chat Lab. We're not doing so well. We're actually in the red on rent, courtesy of COVID. It's a $50 a month PayPal membership that gives you access at this point to a 4 foot by 4 foot pretty high-powered laser cutter. We've got alignment, and we've got we're still setting up, but we've got a 4x4 laser cutter. We will have a 4x4 wood CNC, and we're in the process of putting together a 4x4 plasma cutter. So building just about anything you could imagine. We've got a full machine shop and welders and all kinds of toys, in addition to a computer lab. So check us out on Facebook or the net or whatever, but Chat Lab.
It's also down, it's on the north side, just off Cherokee Boulevard.
If you know where branch development used to be, the 3D printer folks in the bottom floor of Business Development Center, the old 3M building, it's at the corner of Manufacturers Road and Cherokee Boulevard, right there in the old 3M building.
Okay.
You got key fob access 24/7, 365 to the space and the equipment. So pretty cool deal if you don't have space for that kind of equipment, space or money for that kind of equipment. I'm out.
All right. Anyone else?
This is time or space to talk about.
Is that Ned? Yeah, Ned, I can't hear you very well.
I'll tell my wife.
All right, Lynn?
He has to come into the room.
Oh, okay.
I'm sure. Okay.
Is this the place to talk about the Astronomical League?
I don't know why not.
He doesn't know why not. Here, wait a minute. Shit. Well, yeah, you're a pain in the ass.
Well,
Nobody heard that.
That was only 3 letters, Matt.
I'm so sorry.
You didn't
guys
say
are
that.
definitely, you guys are definitely my kind of people, I got to tell you.
So, what was your comment on the Astronomical League, Ned? Or question? Did we cut him off?
Ned, my microphone does function.
Ned Smith here. If you can't hear me, I'll cut it off and talk another time.
I can hear you a little bit, Ned. What was the question about the Astronomical League?
What does it do for us? It's over a third of our budget, and we get this magazine. Are there any other benefits?
Matt, do you want to take that, or Jan? I've been considering the same thing. We do get the reflector. We do get. It is pricey though, and it does take a lot of. They don't make it easy for their members to be members. So. So in general, it's a worthwhile organization, but we have not been taking advantage of all that they offer. Okay, and I think it is worthwhile to talk about, you know, how we take advantage of the opportunities that we have. We know there's a lot to offer there, but if we don't do what we need to do on our end, we're not going to get the value out of it. And I think that's a decision. I think really that's the question, that is what is, given the resources that we have and the people that we have to interact with and to kind of coordinate with the Astronomical League, is that something that makes sense for us? So,
Patrick, one other thing, this is Lynn Dorsey, at least from my brief interaction with them, they are very much for public outreach and education. Yeah. And those resources that may be available, both personal and print, I think are worthwhile investigating. So we don't reinvent the wheel. Yeah, agreed. I think it's just, like I said, it's setting down and organizing ourselves to take advantage of the things that we're actually paying for, you know, the good things that are out there that we are actually paying for. So, all right. Thank you, Ned and Lynn, for bringing that up. Any other activities or any other comments from the membership?
Patrick?
Yeah.
Matt mentioned it, but I think it's worth pointing out that September of 2020 represents the 4-year anniversary of our Star Walk out at Harrison Bay State Park. It's been 4 years since Matt and Ralph and Camby and I'm sure I'm forgetting umpteen people, but Frank, and oh man, it was just amazing the work that was done on that, and it's still out there. And you know, if you want to visit it, get on Google Earth or Google Maps, and you can not quite read each sign, but you can still see all those signs are out there.
I wonder if we could do an article for the newsletter to kind of remind people of what that is. We've had a lot of membership turnover and a lot of new people join the organization since that happened. It's not something that we talk about a lot. And maybe, and I'm not saying you have to write it, Richard, but somebody, if you want to consider.
I'll try and get that for next month.
Okay. Great.
I think that's a great idea.
Yeah. Really, Beth?
How do you do a video walk around?
I'll support that.
Okay. Anything else, anybody? Okay, that is Bill.
Bill had a question. Yeah.
Bill, you have a question?
Yes, good evening. Yes, sir. First of all, I want to say I'm honored to become a part of you guys. I had been a member of the Knoxville Astronomical Society, and when I married my wife, I didn't think the skies were clear enough to be able to enjoy my telescope, so I gave away my C8. So I missed it terribly, so I decided to go out and reinvest, and I recently purchased a Meade 10-inch SCT GPS. So I'm in the process of trying to get that set up, and I look forward to working with everyone and enjoying the night sky together. And finding at least a decent place to look. That's the big thing.
Yeah, well, we have some cooperation with some of the state parks around here, Cloudland Canyon, not Chester Frost, but
Harrison Bay. That's where the Star Walk is.
Bay. Harrison Bay. So we do have some sites that we can utilize. And again, if you're new, I need to get the addresses. I will add new members to the group IO. So I'm going to send a letter out to everyone in the organization.
You should have everything that I submitted.
I'm sorry, what?
I'm sorry. You should have all my information. I got the email from Beth.
I just need to go
and
through.
That's why I'm here tonight.
I just need to go through and get the emails and add everybody to the group IO.
I send that to you every month, Patrick.
Yeah, I know. I'm just, it's a mental checklist for myself, so that things that I need to get done before I turn over to Amy. I'm getting a U-Haul put together with all the stuff in it. So yes, and there's a lot of information on there on the group IO sites. We have forums to ask questions about how to set up equipment, questions about, we're sharing information from different resources around the web. So there's a lot of good information on there, and I'll make sure the new members get at it. It's one of the benefits of being in the club is being able to participate in the group IO chat forums. Okay. Thank you, Bill. Welcome. All right, we are out of time here.
Thank you very much. I look forward
to. All right, so at this time, I'd like to adjourn the business meeting, and I would like to jump into our program. Sorry. There we go. So tonight's program is going to be on the Radio Jove project and the NASA Citizen Science Project. It's going to be presented by Dr. Chuck Higgins from Middle Tennessee State University. And I will turn things over. I will let Chuck introduce himself, and I will shut up and allow you to do what we came here for, which is to learn more about radio astronomy. So Chuck?
Well, thank you very much. I hope everybody can hear me okay. I appreciate the invite. Thanks, Matt, for reaching out. And I looked back and I realized that I had come down there in 2009. And I knew it was, I thought it was longer, but that's because I'm aging faster by the day. So it's nice to be back. It's too bad I can't be with you, but the technology here is pretty amazing. So I'm going to talk a little bit about radio astronomy and public outreach, citizen science, education, kind of all roll into one, and that's this Radio Jove project that I'm involved with. So I'll go ahead and share my screen here, and we'll see if this is going to work. And you tell me if that's okay. All right, great.
Good.
I can see a couple of you, and a few thumbs up floating across the screen here. That's great. Well, thanks again for the invite. Again, my name is Chuck Higgins. I teach physics and astronomy here at Middle Tennessee State. And I've been here since 2001 by way of Huntsville, Alabama, the University of Florida, NASA Goddard Space Flight Center in Maryland as a postdoc. And then I was at Penn State for a couple of years, temporary teaching position before I came to MTSU. And so I'm in my 20th year here. It's amazing, but all's well. And about the time I was at NASA Goddard Space Flight Center in the late 90s, we started then an education project called Radio Jove. And a bunch of radio astronomers got together and developed a kit, a radio telescope that you can buy and build. And sort of one thing led to another, and we're still selling these kits and trying to rope people into doing astronomy at the long end of the spectrum, long wavelength end of the spectrum, and learning a little bit about the universe outside the visible spectrum. So that's really one of the goals, is to science literacy and try to get students, teachers, general public involved in science and using radio astronomy as the vehicle. So I'll talk a little bit about Radio Jove, and then some of our education partners, and then what we do in citizen science. So we started out as an education project primarily, but we kind of ran into a K through 12 buzzsaw, and you know, it's hard to get things into a K through 12 curriculum, and we didn't get very far. So we've, in the last 5 years specifically, we've transitioned into doing more science and focusing on citizen science and getting people to sort of take their observations a little bit more seriously to try to help us answer some scientific questions. So that's been a lot of fun. And at the very end, I want to highlight a few other NASA citizen science projects. You're probably aware there's hundreds of projects out there. So I'll just talk about a few and see if I can excite you and recruit you and maybe into joining some of those things. They're quite, some of them are quite advanced. So just briefly a little bit about Radio Jove. Jove for Jupiter, and we sometimes use capital Jove for like the call letters of a radio station. And we started officially in 1999 selling kits. And what we did, we got some money from NASA to front the first 100 parts for the first 100 radios. And so we buy in bulk and then we basically sell them at cost. And I've got the price on the next slide. But since that time, we have sold over 2,400 of these things. And that's, you know, 70 to 80 per year, which is kind of our average. And we target high school and up, but we've had even some middle school science teachers and classes get involved with us. But we're more targeting after school clubs, science clubs, universities, and citizens. A lot of ham radio folks are excellent because the equipment is very similar. So some of the pictures you see are a few of our people that have bought kits and sent us pictures and antennas set up in different places around the world. It's a lot of fun. It's a very worldwide effort. So we've got kits. We can't keep track of them all, so we don't know if they're all running or not. But at least we know that we've sent them to 70 countries so far. As I mentioned, the kit is the designer of the receiver is a radio engineer who grew up building Heathkit radios, and he wanted, yeah, I'm sure some of you are familiar with those. He wanted to have an experience like that where you actually build the equipment yourself. So we designed the receiver, and I've got it here. I don't know if you can see me, but it's the size of a cigar box or something there. It's about 100 parts. It's a fairly simple design on the receiver. It's not super complicated, but it's really solder by numbers is the way I like to say it. We've got fairly good, we think, construction manuals for the receiver. Beginners can do it. The parts are widely separated on the PC board, so you can start and learn. And if you've never soldered before, it's a great skill, obviously, to have. And this is one way of learning that skill and others building this radio. So that's a lot of fun. And then the antenna that comes with it is a dual dipole. So essentially a dipole antenna. It's a very simple antenna, not too expensive. And it does take up a lot of space. So we operate at 20 megahertz. So that's close to 15 meters. So a half wave dipole, you can see from that image, is 25 feet long with the, and the guy wires, if you include the guy wires, you're talking about almost a 30 by 30 foot square of space needed if you install both antennas, both dipoles. So it's a fairly big footprint, but that's the problem with long wavelength astronomy is you need either humongous dishes or lots of little dishes, or in our case, wires, simple wires, but they work pretty well. And from the beginning to end, of course, is you build it, you operate it, you attach it to a computer, collect data, you can analyze the data. We have a data archive that you can upload data. And so it's a working radio telescope. And it was designed such that you could observe the low frequency radio emissions from Jupiter. So the Jovian emissions are strong enough that simple equipment like this can actually pick up those emissions from Jupiter. And you see a strip chart there from one of our team members, Jim Sky, he's radiosky.com. So the data come into the computer and get digitized by a sound card, and it shows up like a strip chart. And the really slick thing about the software is you can share it. And if you've got the software installed, you can serve out your data in real time, and then others can connect to your antenna or to connect to your receiver and watch the data real time from anywhere. So it's a great way to share and compare, and you can see the whole system is about $300, plus a computer. So it's not too bad. It's certainly not pocket change, but we understand that. But it's a great way to get involved in radio astronomy. So it really is a beginner's system, and we are still operating and selling these kits, and I am the kit distributor. So any orders actually come through me, and I send them out. But on the right-hand side, so as I mentioned before, we're transitioning into more science, more citizen science. So the same radio engineer designed a spectrograph, a radio spectrograph from operates between 15 and 30 megahertz. And these frequencies were chosen because we have to stay above the ionosphere. The radio signals will get absorbed by the ionosphere. Depends on the solar cycle, depends on the time of year, but below about 15 megahertz, and things get you can't do much radio astronomy below 15 megahertz unless you're in space. So and then Jupiter tails off above 30 megahertz. There's not much. It's a magnetic cutoff by the planet, and so it's kind of the sweet spot. And cleverly, he designed that single frequency receiver at 20.1 megahertz with a very narrow bandwidth on that receiver, so you could dial down to 20.0, and actually with one dipole, you can pick up the WWV atomic clock signal at 20 megahertz that they send out of Fort Collins, Colorado. So you hear a beep from that signal, and that's a great test that you've got a working system. But the spectrograph, as you see, is certainly a more advanced system, and you get higher cost, obviously, and a wider band antenna, but you can gain a lot more information about it. So I'll talk a little bit more about that in a few minutes, what those spectrograms are telling us. But you're looking at a few $1,000s for this kind of thing. Now we are also trying to cut the cost by using these software-defined radios. These are now ubiquitous, And some of these are actually pretty good for doing radio astronomy. So we're working with several people to make that happen. But so we're transitioning into some more the science side of things, and we're looking for people to get involved and help us. So here's a slide showing a few of the research interests. Of course, we're interested in learning more about Jupiter and Jupiter's radio emissions. And the telescope works very well for solar emissions. So when the sun is active, you've got magnetic activity on the surface of the sun, and that leads to radio emissions. And this is a semi-classical mechanism here. So what the cause of these radio emissions are electrons moving, spiraling in magnetic field lines. So Jupiter has a very strong magnetic field and lots of plasma, so therefore lots of electrons. Same with the sun. And so these electrons are moving at near relativistic speed. So we're sort of still in the classical realm of moving electrons. But so you get these bursts of energy from the electrons that are moving, and that leads to radio waves propagating through interplanetary space, through the Earth's ionosphere and down to the ground. So we can pick up these things fairly easily. One thing that we're also moving into, we have a scientist at NASA Goddard that is doing ionospheric stuff. So the radio waves that propagate through the ionosphere can tell us something about the ionosphere. Where does the ionosphere cut off? Again, coming from the outside. And you can use ionospheric sounders, and ham radio folks know the ionosphere very well because you're using the reflectivity of the ionosphere to bounce your signal around the world. But we can use signals from the sun and Jupiter to help us understand radio wave propagation. And then, frankly, we can learn a little bit about the galaxy as a whole, because the background emission, let me go back a slide. The background level that you see there on that strip chart is the Milky Way galaxy, assuming you have a quiet site, a radio quiet site. That background is due to electrons moving in the galactic magnetic field. So that's our background level, and then we measure everything relative to that level. Anything above stronger emissions above the galactic background is and that could be a lot of earthly interference, where these telescopes are very good at detecting lightning. And so we have to warn people to be careful, any lightning coming nearby. We tell everybody to unplug everything. But you can detect lightning from hundreds of miles away with these things. And we radio astronomers, we have it good in certain ways. We don't need a clear sky. We can typically operate in the comfort of air conditioning or heating. We're not out there in the elements. So that's certainly nice. However, we are just as susceptible to pollution as you are. Light pollution and radio frequency interference, RFI pollution, and it's everywhere. So we're in no better shape than you are. So we're also running around trying to find dark skies, and it's actually some fairly interesting science trying to find where the interference is coming from. A lot of power lines or solar panels are terrible, and solar panel inverters, LED lights in some cases. These you guys remember the clap light bulb? Those are terrible. The touch lights, they're just beaming radio frequency interference everywhere. They're not filtered. So electric blankets are bad. It's really maddening in some cases to try to find where your interference is coming from. But you know, it's a challenge, so we're doing the best we can. Where you know, basic project would be to simply just build your own radio telescope, and then, you know, as you get more advanced, you learn it, you can make observations and try to analyze or compare your observations to others, and then of course do more advanced spectrograph work if you so desired. I like this figure on the right. It shows both a spectrograph view and then the single frequency view at 20.1 megahertz. So a solar burst, or in this case, several, a strong solar burst and several weaker ones. The strong solar burst you see when you increase the time resolution, you see it's made up of a lot of individual smaller bursts there. And so you can you know, learn something about how the plasma around the sun is behaving when these solar bursts go off. But that gives you a kind of an idea that you can learn a little bit more using the spectrograph, because you're looking at the spectral signature. And in our case, we also have polarization. So we have right hand and left hand circular polarized antennas, the capability of detecting polarization, and that tells you something about, you know, the physics of what's causing these emissions. I'll just briefly mention that we, Radio Jove, 4 years ago, started partnering with this group out of NASA Goddard. It's a space science education consortium. And so there's 26 now, I think 27 partners around the country that do citizen science, NASA education and outreach. And so Radio Jove is officially part of that group. So that's been a real help for us. We've gotten some funding from that group. We partner with citizen scientists, you know, like yourselves. Society of Amateur Radio Astronomers has been a great group for us. And we have right now 12 different individuals with radio spectrographs set up around the country. You can see it there on the map. And we're trying to build a network of more sites. That way we get better coverage of ionospheric changes, or things like the solar eclipse. We made measurements, things like that. We want to make have more of an impact scientifically. We have an informal kind of an agreement with the Jupiter, the Juno mission at Jupiter. So the sites that you see there are operating basically 24/7, collecting data. And there's a radio instrument on the Juno spacecraft. And basically we're there to corroborate any data if needed from them. But they haven't called us, but we archive our data in case they do want to see what an emission event maybe looked like on Earth compared to what they saw with the spacecraft. And then we are archiving our more scientific data at the NASA Planetary Data System. It's not publicly available yet. We're going through a peer review process right now, but we do have other places where we archive our data, because we want people to use it, to have access to it and use it. I want to stop here, I'll pause just for a second in case there might be any questions. I'll open up the chat window, or somebody can open it and tell me if there's a question. And I'll pause just for a minute, and then I'll keep going.
Can you go over the footprint again and the requirements? Does it have to be flat ground, or can it be on a hillside as far as the array? Yeah,
that's a great question. So the footprint is, so the dipoles have to be a quarter wave up off the ground. And the reason for that is because the ground acts as a reflector at 20 megahertz at 15 meters. And so essentially the water in the soil is highly reflective at those wavelengths. So
So basically 4 meters, close to 4 meters off the ground then.
no,
You said 15, quarter wave at 15 meters?
yeah. So we're, is that right? Well, it's a half wave dipole. So we're only up 10 feet. 12 feet would be ideal, but the PVC poles and conduit poles come in 10-foot sections, so we're okay with that. But yeah, you're up a quarter wave, and you need to have enough. A desert won't work. Desert soil won't work. You can put a ground screen down like chicken wire, and that could be your ground plane for the antenna. So the dipole is 23 something feet plus a little bit on the ends for insulators, and then the pole. So it's about 25 feet. And then if you need guy wires, you're going to add a few more feet on each end. So 30 feet is a good number. And then the one dipole actually will work. It's just less sensitive. So you can pick up solar bursts with just one dipole, or extremely strong Jupiter burst. But if you want to detect more Jupiter, you need the second dipole there, and you bring them together in with a power combiner, and then run the cable. Everything is coaxial cable, and you run that into your receiver. So the dipoles are separated by about 20 feet, and you can have them on a hillside. Typically, I mean, as long as it's not too steep, you're not going to affect what we call the antenna pattern. Where is the antenna sort of sensitive on the sky? Now, if you have equal lengths of cable from the two dipoles, your antenna points at the zenith. But you can play games. You can add cable and a delay line and take your antenna beam and move it in the sky. And of course, the sun and Jupiter are in the south. So we want to point towards the southern skies. So if you're on a hillside that faces a little bit south, then that's great. You're not going to really affect the beam pattern too much.
What would kind of be the field of view, the angular field of view of the typical array?
Yeah, so these long wavelengths are hard to get angular resolution. So this is roughly a 60 by 60 degree beam on the sky.
Okay,
so it's big.
So it's not like you have to wait for Jupiter to be just in the precise spot, or the sun. You can kind of point it at the ecliptic, and as those things pass overhead, you'll catch the signal.
That's exactly what we do, right? And we typically get about 3 or 4 hours when the Jupiter or the sun is in the beam. But you're just going, you're just going less sensitive if you're a little bit outside the beam. So it's not unprecedented that you could detect something. It's just not as likely.
And as far as setup, say you set the array up, I assume that's the long portion of the setup. Could you just have a coax quick disconnect, pull the electronics, and we could have this set out someplace, go to the site, plug the electronics in, and use this?
That's right. The combiner at the center of the array, we typically put it in a piece of Tupperware to keep the rain off of it. Yeah, you just disconnect it there, and you could leave your antenna if you have a semi-secure site. Leave the antenna set up. I've had one set up for years, and we've got a dairy farm about 9 miles from campus. I had one set up on campus, but campus, what do they call them? The master plan people, they don't like it too much. It's not the most beautiful looking thing, and the lawnmower folks, the grounds crew, hate them because they've got to mow around the antenna, so they're not fond of it. So I found a place out out in the field, an empty field in our dairy farm. It works pretty well. I leave it plugged in. I'm taking a risk because of course there's lightning, but I have it remote and it runs 24/7.
I've got a quick question.
Uh-huh.
I've actually got, I'm popping in and out. I apologize. My name's Kevin Masoulis. I know I'm guest, my first use on this platform too. I've got one of your antenna setups, and I've got the receiver kit here in Chattanooga for Patrick to hear. My quickie question: which way would you put the dipoles? I mean, line north south on a hillside, or east west?
Yeah, well, that's great. I knew there was a couple of kits down Chattanooga way. I didn't know who had them, but yeah. So we typically prefer that you run the wires east-west, because that way, when you put your delay line in, then you can point the antenna to the south. If your wires are running north-south, then if you put a delay line, you're gonna knock it over towards the east or towards the west. Either way, it will work, but it's more preferable to run the wires themselves, the dipoles run east-west.
Okay, cool. I'm actually going to take a walk in the backyard here in a minute. I've got somebody coming, so I'm going to have to drop out again. But you said basically 20 feet separation between dipoles, and they're about 25 feet long.
That's right.
Okay. I appreciate it. I'll be back in. I think my tree cutter just showed up. I'll be back in the group here a little bit. Thank you.
Okay, sure.
Yeah, I have a question. We have 2 of your kits and at Dalton State College. And I was wondering about the polarization data. Is the software set up for that, for looking at the polarizations?
So there's actually 2 pieces of software. Well, let me back up. So the kit itself, the one on the left, is single polarization. So it's only these wires are going to measure linear polarization. And so you're only seeing one, you're only seeing the linear component.
Mm-hmm.
And the spectrograph software, and I didn't talk about this in detail, but essentially that antenna is a square antenna.
Oh, so you can get, yeah.
Yeah, so what you do is you've got then the 2 dipoles give you one linear component, and the other 2 give you another linear component, and you can mix them and you get the right hand and the left hand. That software will show you both polarizations if you have that kind of antenna set up.
Okay, fantastic. Thanks.
And it's the sky's the limit in a way on these things, because you can actually take a Radio Jove dual dipole and you can build 2 more dipoles and make it a square. And you would need 2 Radio Jove receivers to do it, but then you could mix those 2 signals and there's a pretty easy way of doing it. Mix those 2 signals and then output, one is right-hand circular and the other is left-hand circular. So you would have, each receiver would be 1 polarization.
Right.
Chuck, that is Dr. Blair.
Oh, from Dalton State. Well, great. That's it's really nice to meet you. I hope we can work together. I'd be happy to help you with your kits in any way I can.
Fantastic. I wrote your name down, and I'll be getting in contact with you. So
sure. Happy to hear from you.
Great to see your presentation.
Okay, great. Sure thing.
Dr. Higgins, I have a question, if you don't mind. You mentioned about the galactic background. I actually had not been familiar at all too much with radio astronomy, so this is relatively new in my spectrum. The galactic background, if you could point your mouse to where the galactic background is in relation to this
part
strip
of
chart
the spectrum,
for reference.
say at the very end on the right hand side. And I think I've got some others later in the presentation. I can point that out again, but it's essentially the lowest level that you're seeing on the chart there. And assuming you don't have any local interference, you would have a nice flat background, and then anything on top of that would be emissions that are stronger than the galaxy. You know, we're in it, and there's no getting around it. So we have to use that as our baseline.
Yes, sir. Now, do we have any
Yes,
idea
this was
why
discovered
Jupiter
accidentally
is
in the 50s,
generating
and
these emissions?
by taking more data and understanding the periodicities that happen within the system, they've found, well, it's moving electrons in the magnetic field. So those electrons have to come from somewhere, and there's two sources. One is the solar wind plasma. So there is a component that is emitting basically all the time, but it's weak. And well, it's emitting all the time, but it's tied to Jupiter's magnetic field, which is rotating once every 10 hours. So we have a 10-hour periodicity of seeing those emissions. But then the other stronger emissions that was discovered in the early 60s was the moon Io is a plasma source. Because it's volcanic. It emits neutrals into Jupiter's magnetosphere. Well, those neutrals get hit with the solar UV light, and they get ionized immediately. So you've got this whole ring, whole donut of plasma around Jupiter called the Io plasma torus. And then because the magnetic field lines move through, I have this on a slide. I should just go forward and tell you. There we go. This slide shows you, this little cartoon on the right shows you Io and the torus, and the field lines that cut through Io, then there's an electrical connection between Io and Jupiter's, the top of the ionosphere. And so essentially you've got moving plasma, moving electrons along those field lines, and those electrons get accelerated and then emit energy in the form of an electromagnetic wave, coming in as the cartoon shows you, coming in like a cone shape, and that gets emitted out into space. And when Earth or whomever is in the line of sight of one of those emitting cones, then you pick up Jovian radio emissions. So there's some very interesting physics going on.
Thank you.
Okay, I'll keep going here. So just briefly, citizen science, NASA has really gotten into this game and is promoting, they're putting money into citizen science. And so they want to have individuals collaborate with scientists to help do more science. So Radio Jove, and there's a few others that are part of the NASA citizen science team, part of this space science consortium. One of our citizen scientists is in North Georgia. He is, Jasper, there it is. Jasper, Georgia, not too far from you guys. That's his Radio Jove and radio spectrograph setup. So he's got it all plastered on this, I don't know, big board there. He's got 3 monitors that he runs. You can see on the right-hand side, there's the Radio Jove receiver, and he's got the spectrograph here on the lower left, and then he's got 2 SDR Play digital spectrographs running, and then these 2 are computers right here. He's got quite a setup, so he's one of our more excellent observers, and has really jumped in with both feet to do radio astronomy with us. So that's quite intimidating, but you can see how far down the rabbit hole you might get here. For some of you, you may have heard this, but I always like to play what a solar burst sounds like. And that's what it looks like on a single frequency spectrum. So let me play this little clip for you. I got to turn up my volume. Sorry about that. So it's a very sharp rise, and this is white noise, and then a slow, more gradual decline. And that's a consequence of the bubble of plasma that's coming off the sun expanding and sort of weakening, so to speak. And as it moves, we get a blast, an initial blast of radio waves, and then a lower intensity as the bubble expands and the electrons are moving around in that plasma bubble. So that's kind of fun to actually listen. And your computer then, because you're digitizing the I should have said that the radio Jove receiver, the output is audio. It's an analog signal that you can actually connect a simple speaker and actually hear the output. And that is a great way to identify, because the sun has a unique kind of sound signature, and so does Jupiter in some cases. And so I'll play at least one example of what we call the shorter burst, the S burst.
Jovian S burst activity.
So each one of those pops, it corresponds to that, those spiky looking things on the spectrograph chart above it. And you can see the difference between that chart and that chart. This chart here has a slightly different look to it because those are what we call L bursts or longer bursts. And and the difference is in the acceleration mechanism there, but it's amazing. It shows up on this simple equipment, these two different kinds of bursts. And with more advanced equipment, if you record this stuff at high speed, you can get the spectral characteristics and the temporal characteristics, but slowed down by 128 times. So here's what that sounds like. So each pop that you heard is the whistle there. It's going from high to low frequency. And the cool thing about that is that tells us that the electrons are not moving towards Jupiter, they're moving away from Jupiter, because the magnetic field gets weaker as you move away from Jupiter, and the frequency is tied to that magnetic field strength, and so you get a lower frequency, lower pitch noise source there. It's kind of cool. With long-term observations, and this has been known since the 60s, we built up a probability map of when Jupiter is going to emit, when the probability is high for it to emit a radio wave towards Earth. And so there's 4 different zones related to where the moon Io is in its orbit. So there's Io A, B, C, and D. And so we keep adding to this probability map to help us understand the boundaries of the radio emission and maybe some strange signals that don't correspond to these particular zones. So that's something that we're always doing, adding to the map. With the spectrograph, you can obviously get more information out of it, polarization, and then the spectral information. And what you see here is a Jupiter event, which is very bursty across the plot is going from 15. Nope, that's not true. This one is 17 to 26 megahertz, and the intensity is shown in the brighter colors there. And you see some spectral features, and some of those, the more horizontal lines is due to the Earth's ionosphere. And then the more diagonal lines is actually due to propagation effects as the radio wave is propagating through the Io plasma torus near the source. So you can garner some local and local to the source and local to the observer, some emission propagation effects here. And just as a comparison, the strip chart below is what you would see on a single frequency radio Jove setup. Here is a solar burst that was picked up at 3 different sites. And again, the strength and the color bar shown there shows you the strength of the signal. And you notice that there's a lot of characteristics, some structure in these multiple solar bursts. Horizontal bands on the spectrograph are interference. So those are usually stations, or it's hard to see it, but the top of the diagram up there, near the top of the diagram is a line that's due to CB radio bands. And the stuff at the very lower edge is quite noisy because we're getting near the ionospheric cutoff. And so we're getting a lot of reflected signals from radio stations and other things. But the sun comes through, it penetrates through the ionosphere, and then notice the big burst here has a lower frequency cutoff. So that is a way to tell you the absorptive properties of the ionosphere. So it's frequency dependent and it's latitude dependent. So that's why we want more of these stations set up, so we can better understand the ionosphere. So that's Murfreesboro and Florida, and then Pennsylvania, those 3 charts there. Here's a spectrograph chart showing hundreds, or not hundreds, but dozens of these vertical swaths there through the spectrogram, through the spectrum at 15 to 30 megahertz. Those are weaker solar bursts. And if you notice real carefully, these faint diagonal lines, those are ionospheric sounders. So they send a signal at low frequency, higher, 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 and they are usually on the coast of Florida, and they are looking at the ionospheric conditions, and in some cases they're using it to monitor drug trafficking off the Florida coast. But we actually pick up those ionospheric sounders there as this slanted, we call them sweepers because they kind of make a sweep up through your spectrum. Well, I should mention this actual spectrum came on August 21st, 2017, and the sun was quite active that day. And then right in the middle of the diagram here, you can see that was totality in Murfreesboro, Tennessee. So we are looking for evidence of whether the lunar shadow affected the ionosphere enough to affect the propagation of the solar radio waves that happened that day. Something that I have been working on, and many of my students, we want to just simply count the number of solar bursts at 20 megahertz over time. So what this plot shows you is the middle plot there is the basic sunspot number, and The top plot is the solar radio flux at 2,800 megahertz, and that's been going since the early 90s. And I think that's a Canadian university that has been monitoring that for a long, long time. But I wanted to find out whether there was a similar kind of periodicity for the lower frequency, the 20 megahertz solar counts. So you can, with a spectrograph, you can count them fairly easily this way, or you count them up here on the top plot as just the solar bursts. If you have well, we don't need a 24-hour plot. We need a 8 or 10 or 12-hour plot just for daylight hours. And we simply count the solar burst every day and plot them. And so I've had some students over the years do this, and we're building up our statistics to have a longer term solar radio burst count plot. And I want to make that a citizen science project where people could actually analyze those data and add to the plot themselves. They don't even have to take the data. They would actually just help us count the sunspot, solar radio burst that we receive. Typically, that's right. But yes, we have done that. MTSU does have an H alpha telescope, but I've never done a side by side, sort of in real time. But we know, we look at I'm trying to think of the telescopes that's always pointed at the sun, like SOHO and some of the spacecraft telescopes. And we try to correlate. And in some cases, we can figure out where the active sunspot is. And that's simply by looking at the optical or looking at the X-ray emission or the UV emission that comes from the flare themselves. Yes, so there is a strong correlation there. I'll quickly just go through this. So we're trying to get involved with studying the galaxy, again, over long term. We can use our spectrograph data to look at the Jovian signatures, the spectral characteristics in the upper right there in a little bit more detail. This one in the lower left is kind of cool. This was a pattern that we started to see on our spectrographs at the same time, different parts of the country. And so we worked through this thing, and these pyramid-shaped looking things on the spectrograph are actually caused by lightning and the echoes or the refraction that the lightning is off of the ionosphere. And so from that, we actually got a paper published. So this is out this year. So this is our first science paper based on citizen data. So we're quite proud of that, and we hope to keep going and doing some of this. This is our solar eclipse. We had several people set up radio Jove telescopes, and a lot of them got bombarded by local interference or other problems. And out of 25 or so setups, we only got about 7 or 8 really good data, good quality data, and then the spectrographs at different sites. So we're trying to look for statistical evidence or I'm trying to look for evidence, and still looking, by the way, that the the moon's shadow had a noticeable effect on the ionosphere. So hoping to come to some conclusions soon. And then, of course, we'll plan for the 2024 solar eclipse and maybe do the same thing again. So just quickly, this summary there is Radio Jove is an active citizen science project where we've got partners. We want to look for more partners. If any one of you might be interested in getting involved, we be happy to talk with you and help expand our network. And that's been a fun project, and we're happy to continue that and going forward. So we've got a fairly populated website there, radiojove.gsfc.nasa.gov, if you want to learn more information about that. So I know I'm getting kind of late here. Let me just run through a few slides of some other NASA citizen science projects. So if you just Google NASA citizen science, you'll find their website there. And they are really, there's a whole list of projects that they have on their site there. And as I said, they're really looking to add and improve, instead of formal lessons in the classroom, they want to have, they're not neglecting that, but they're trying to expand their sort of education in a way by drawing people in by doing science. And there is an incredible number of ways to do it. And I went to a conference, was it last year or year before last, and learned so many different projects that are out there. And so I'm just going to highlight a few of these. So SciStarter.org is a clearinghouse for citizen science projects. So that's a great site to go see and find out about the different projects. They've got a lot of them. You have weather stations, or you look at insects or water quality, plants. There's one for the flu. You can track where the flu is going each year. So that may be something quite useful these days. Your public libraries have great spaces for doing projects. There's maker spaces. In a lot of cases, students or classes can check out rain gauges or other tools. If they don't have the tools, they can get them at the public library to do science kinds of things. So there's I'm just going to highlight 5 or 6 or 7 of these things. So SunGrazer is a way to find comets. So NASA provides these data, these images. In some cases, they're movies of solar data where you actually see comets moving, and you're identifying these things from looking at these NASA or European Space Agency telescopes. So that's called SunGrazer. There's a guy at NASA Goddard that has developed a whole cadre of experiments for, K through 12 and anyone really, experiments that you can do with your smartphone. There's a lot of, as you know, there's a lot of tools or apps that you can download for sound or light intensity. There's a module you can attach to measure pressure. Of course, they all have accelerometers on them. There's magnetometers. There's a plug-in for detecting radioactivity. It's amazing. So he's got a book that he's written, and you can see all these different experiments that you can do with your cell phone. So that's a real low barrier of entry for some of these to get involved in some citizen science. And I'm sure you guys are well aware of the Globe at Night program. So they're looking at light pollution and the sky brightness. And of course, that's related to energy consumption and, affects wildlife and our health. And so there's a web app for that. So that's a real fun, simple way to get involved. You just go outside, look at the stars, and count how many you see at your location. And that how many stars you see for a particular constellation tells them how what your sky quality is, essentially. So that's kind of a fun project. And then similar to it, they have a globe observer where you're looking at the Earth, and you're looking at either cloud cover or looking at mosquito populations or tree growth. Or I heard a talk last week or 2 weeks ago. This woman in Washington has a group of citizen scientists going out on the beach and not only documenting dead birds, dead seabirds, but they actually pick them up and take them and do some simple, I guess, analysis of why these birds died. And so a little bit gruesome, but apparently there's enough people that like to do that. So they're learning about why these birds are, it's climate change and why these birds are changing, feeding grounds, that kind of thing. It's really quite fascinating. You also may know NASA has a whole list of solar system ambassadors. And so if you go to their solar system ambassador website, you can actually look up where ambassadors are located. So there's I don't know how recent this is, but there's a list of some of those in Tennessee, and there's a few names. You might recognize a couple of these names that are local, and they have resources. These are great for schools. These are great for clubs. They have resources, handouts. They have programs, projects that they do. They have a calendar of events. So if you want to tap in, the solar system ambassadors are quite good. It's a quite a good resource. I have a colleague at NASA Goddard that developed this program called Aurora Sora. So we're not the right latitude, unfortunately, but if higher latitudes, you can actually document the aurora. And they had a breakthrough by the citizens that were noticing things that the scientists didn't. And they found these streamers, these you can see there in the purple, those little streamers that are going across the sky there. Those are called the thermal emission velocity enhancements. They nicknamed the thing Steve. But that was discovered by people with good eyes, keen eyes. And so you don't have to be, a formally trained scientist to contribute. So it's really quite an array of things that you can get involved with. And you may know also about Galaxy Zoo. This is a very famous one where you log in and you take a tutorial. I did this a few years ago, and the tutorial only takes 30 or 40 minutes. And then you can start classifying galaxies. And this is, they do this where thousands of people classify the same galaxy, and they will use those to essentially classify an unknown galaxy. So it's quite accurate with the way the software is set up. And then Galaxy Zoo is also a platform for lots of other projects. And the last one I'll show you here is called Backyard Worlds Planet 9. So you're using NASA's Wide Field Infrared Survey, so an infrared telescope, to look for blobs in the blackness of space that you wouldn't think are anything else. But if you have multiple images, you would see a blob maybe moving, or you would discover, potentially discover objects typically outside the orbit of Neptune. So brown dwarf objects or Kuiper belt objects, that kind of thing. So, and you're just scanning data that NASA provides for you. So that's just a very short list of the different projects, citizen science projects that NASA and others are doing. So I just wanted to give you a brief overview of some of those, just maybe to excite you and to allow you to pass along this information to others, and it's a great way to you know, spend your time while you're sitting at home like everybody else, right? Thank you so much. I hope I didn't go too long there, but I appreciate the time, and I'm happy to hang around and answer some questions for you. Thank you, everybody. I appreciate your attention.